Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, my topic is how to do velocity analysis of a four-bar mechanism. So here we are going to do velocity analysis by using instantaneous center method. As we discussed in previous classes, that there are two methods are there in order to calculate the velocity values of velocities of various mechanisms or various links of a mechanism by two methods. Number one, relative velocity method, and number two, instantaneous center method. By using a relative velocity method, we can calculate the velocities and accelerations of various links of various mechanisms. Now we are going to study to calculate the velocities of various links by using instantaneous center method. Instantaneous center method, in simply we can also call it as a I center method. Now here, let us in this session already just to summarize how to calculate the six link mechanism. Yes, this is a six link mechanism. Whenever going to start to find out the velocities of any mechanism, what to do? We have to find out the number of links. In this mechanism, the number of links are link 1, link 2, 3, 4, 5, 6. Okay, this is also fixed link 1. It is a 6 link mechanism. The number of links, capital N, small n, equal to 6. Then we have to find out the number of eye centers. The number of eye centers, capital N, equal to the formula for number of eye centers, n into n minus 1 by 2, where n is 6, 6 minus 1, 5 by 2, that is 15. The number of eye centers are 15. So after the second step, the first step is finding out number of links. Second step, finding out the number of eye centers. Third step, what are the eye centers are by using links versus eye center table. That table we have to follow. 1, 2, 3, 4, 5, 6. This is horizontal, represents horizontal line. We have to number of links. Now combination. This is 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Next, with the 2, 2, 3, 2, 4, 2, 3, 2, 4, 2, 5, and 2, 6. Combinations. Next, with the 3, 4, 3, 4, 3, 5, and 3, 6. Next, with the 4, 4, 5, and 4, 6. With the 5, only 5, 6. If you count all the eye centers, the number of eye centers in this is, how many are there? 5 plus 4 plus 3 plus 2 plus 1, total 15 will come. So these are the eye centers we have to mark. Then the number of the I12, what are some of the eye centers can be marked directly by visual inspection of the mechanism. So link 1 and 2, one more is there. In order to find out, these are the types of eye centers of total 15, and how to locate those eye centers are with the help of the figure, that is hexagonal figure. The number of links are located like this in a clockwise direction. Then join 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, and 1, 6. In this manner, we have to locate. Suppose if we want 1, 3 eye center, I13 is joining of there are two lines by using Arnold kinetics theorem. that is 1223 extension and 1434 extension. That intersection 1223 1434 intersection extension comes 13. So thus we have to locate the eye centers. In this figure it is located 1 2 2 3 3 4 2 4. How it comes? 2 4. The 2 4, where is the 2 and 4? This 2 4 intersection, how the 2 4 is intersected here? This 2 4 is the joining of 2 3 3 4. Where is 2 3? And it is 3 4. 2 3 3 4 extension. Next, what is the next line? 1 2 1 4 extension. This is 1 2 and 1 4. Where is 1 2? This is 1 2 and 1 4. This is 1 2 1 4 extension joining. This intersection gives 2 4. Okay, just by joining, this table is so important. This is so important. With the help of this, we can locate all the eye centers. So after this location, what is this? What they given in the data? The data was given here. It is the crank OA rotates clockwise at 150 revolutions per minute. The crank OA, that OA is the crank OA. That OA is nothing but a link to OA. Here it is O and A. That is link to. That link to is omega 2. That omega 2 equal to, we found that omega 2 equal to 2 pi n by 60. 2 pi n by 60. 2 pi times n 150 by 60. That is 15.7 radians per second. Thus we have to find out the 2 pi n by 60, 15.7 radians per second. So VA equal to omega 2 times OA, that is 15.7 times 0.1, that is 1.57 meter per second. Okay, thus we have to find out the eye centers, and by using this relation VB by VA equal to 1334 by 1323, that is from this relation VB comes VB equal to 453 by 265 times 1.557, that is 2.66 meter per second. By using this relation VC by VB, that is QC by Q equal to VC equal to 100 by 200 times 2.66, that is 1.33 meter per second. Thus we can find out the angular velocities and the linear velocities of a 6-link mechanism. So in the slides I have shown all the procedure, how to find out, how to calculate all the links. So in a pin jointed 4-bar mechanism as shown in figure, AB equal to 300 millimeters, BC equal to CD equal to 360 millimeters, and AD equal to 600 millimeter. AD here it is a fixed link. The angle BAD, the angle between BAD, that is the angle between AB and AD link is 60 degrees. The crank AB rotates uniformly at 100 rpm. Locate all the instantaneous centers and find the angular velocity of the link BC. So here we have to locate all the eye centers, that is instantaneous centers, and also find the angular velocity of the link. What is that link here? BC. We have to find out the angular velocity omega BC, and we know they did not provide anything, and they have given n of AB. From that n of AB, omega AB equal to 2 pi n or AB by 60. That is 2 into pi times, what is the NAB here? 100 revolutions per minute by 60. From that omega AB comes, after calculating omega AB, we have to find out the angular velocity of the link BC by using, with the help of Arnold-Kennedy's theorem, and also angular velocity ratio theorems. By using these two theorems, we can locate all the icenters of this 4-bar mechanism, and also angular velocity of the link BC can be found. So, how to start? We have to redraw this space diagram into our worksheet. Then after drawing this, we have to locate icenters with the help of Arnold-Kennedy's theorem, or three centers inline theorem. Now, after drawing this configuration diagram, take a scale. How to start drawing? We have to take a scale. Take a scale of 1:5. Then the 600 millimeters by 5. Like that you cultivate, or 1:10. We can take it 1:10 also. So if you take maximum scale, the accuracy will be low, and if you take minimum scale, accuracy will be high. So here omega AB equal to 2 pi n by 60, that is 10.47 radians per second. After finding how to find out all icenters, here how many links are there? There are 4 links are there. Link 1, link 2, 3 and 4. The number of icenters equal to n into n minus 1 by 2, where n is 4, n minus 1, 3 by 2. That is 6 icenters. What are the icenters are? The icenters number is 6 with the help of this formula. The icenters are with the help of number of links and icenters diagram, that is 1 2, 1 3, 1 4, 2 3, 2 4 and 3 4. These are the icenters. After calculating the icenters, we have to locate, these are the icenters. How to locate? 1 2, this is a link 1 and 2, 1 2, 2 and 3, 2 3, 3 and 4, 3 4, 1 2, 2 3, 3 4 and 1 4. Okay, after that what to do? 1 3 and 2 4 are required. So 1 3 and 2 4 comes with the help of another diagram, that is called circle diagram. 1 2 3 4, 1 2, 2 3, 3 4, 1 4. So we want 1 3. This 1 3 is on the coordination of, or extension of, or intersection of 1 2 2 3 straight line and 1 4 3 4 straight line. Where is 1 2 2 3 straight line? This is 1 2 and 2 3. Make a straight line. 1 2 2 3 straight line. Next 1 4 3 4. Where is 1 4 3 4? This is 1 4 and it is 3 4. Draw a line. That intersection gives icenter 1 3. This is 1 3. Next, after that what to do? We need 2 4. Join link 2 and 4. This link 2 4 is the intersection of, link 2 4 is the intersection of, or the intersection of two straight lines of icenters. 1 2 1 4. 1 2 1 4. Where is 1 2? This is 1 2 and it is 1 4. You can write down in the both sides. 1 2 1 4. Then next one 3 4 and 2 3. This is 3 4 and it is 2 3. This intersection gives icenter of 2 4. Thus we located all icenters of the given problem. Then after that what to calculate? We know omega 2, that is nothing but angular velocity of link AB. So in this angular velocity of the link AB, we know that angular velocity of link AB, that is omega AB, and we have to find out angular velocity of the link BC. So VB equal to omega AB times AB, that is omega AB equal to 10.47 meter per radians per second, and AB is 0.3, that is 3.141 meter per second. We know the VB, this is the angular velocity of the B. This B is connected to two things. One is link 2, another one is link 3. So how to calculate? Omega B equal to, that is VB, another formula is that omega BC times this link I13B. Where is I13B? This is I13 to B point. That is omega BC times I13B. We know that I13 to B. Where is I13? From this distance to this point B. We have to measure. That if you measure, it comes as 500 millimeter. That is nothing but 0.5 meters. We want to find out omega BC. We know VB. Then omega BC equal to VB by I13 to distance B. What is that VB? That VB we got 3.141 meter per second. And what is the distance I13B? Is 0.5 meters. Then it is 6.282 radians per second. Omega BC equal to 6.282 radians per second. So that is our objective. We calculated here, that is angular velocity of the link BC. So once again, we have to look at the eye centers. So there are three types of eye centers. Number 1, fixed eye centers. Number 2, permanent eye centers. And 3, neither fixed nor permanent eye centers. We can locate directly eye centers with the help of some of the eye centers. The first two types, that is fixed eye centers or permanent eye centers, can be located directly by visual inspection. And neither permanent nor fixed eye centers can be located with the help of Kennedy's theorem. So that Kennedy's theorem says that when three links are having relative motion among each other, their eye center lies on a straight line. So by using that, what we are going to do with the help of the circular diagram, we marked, and by using circular diagram, we located the unknown. What are the unknown eye centers? Are neither fixed nor permanent eye centers. In this table, number of links versus and eye centers table, 1, 3 and 2, 4 are comes under the category of neither fixed nor permanent eye centers, and 1, 2, 1, 4 are 1, 2 and 1, 4 are fixed eye centers, and 2, 3, 3, 4 are permanent eye centers. So for every mechanism having these three kinds of eye centers, number 1, again fixed eye centers, number 2, permanent eye centers, and 3, neither fixed nor permanent eye centers. So we have to locate all these eye centers with the help of the formula. Here there are three things are there. Number 1, again formula for number of eye centers. Number 2, what are the types of eye centers? And number 3, how to get all eye centers. These three diagrams are these three items are very important. Then we go for marking. So how to start the problem? We have to start the problem by redrawing the configuration diagram, and we have to locate the eye centers. So it depends upon the dimensions of the links of your mechanism. We have to consider the scale, either reduction scale or maximum the scale. Maximum, many times it comes under the category we have to use the minimum scale, reduction scale. That is 1:10 ratio or a 1:8 ratio. Okay, we have to use optimum level, not low, not high. So if the scale is very low, reduction scale ratio is very high level, then what will happen? What will be happening? What will be happening is that the accuracy of the results are very poor. Okay, that is the manner we have to calculate. We have to calculate the unknown angular velocity link BC. That is observed as 6.282 radians per second, and omega AB, angular velocity of the AB, is 10.47 radians per second. So the angular velocity of BC is lower than the angular velocity of AB. That is what, in that manner we have to calculate. Okay, next. The next problem, again, we have to locate all the eye centers, all the instantaneous centers of the slider crank mechanism as shown in figure. The length of the crank OB, that is 100 millimeters, and connecting rod is 400 millimeters. If the crank rotates clockwise with an angular velocity of, again crank rotates, here crank OB, in angular velocity of 10 radians per second. Find the angular velocity, find the velocity of the slider and angular velocity of the connecting rod AB. Velocity of the slider VA and angular velocity of the connecting rod AB. These two things we have to calculate, and also we have to locate all the eye centers of rotation, all the eye centers. We have to calculate, we have to locate all the eye centers of the given mechanism. Okay, how to calculate again? We have to redraw the space diagram again. And what are the, again, how many links are there? This link 1, link 2, link 3 and link 4. The number of eye centers equal to 6 for 4 links, 4 bar mechanism. What are they again? Mark it 1, 2, 3, 4, 1, 2, 1, 4, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. This is second step. These are the eye centers. The eye centers here, 1, 2. This is 1, 2, 2, 3, link 2 and 3, eye center 2, 3, 3 and 4, it is 3, 4. Next, 1 and with respect to 4, I1, 4, it is at, where it is? At infinity. 1, 4 at infinity. So these are fixed and permanent eye centers are located. Now, what is the next step? 1, 3 and 2, 4 are neither fixed nor permanent eye centers. In these nor permanent eye centers, we have to use circle diagram. The circle diagram is, it comes by the extension of the circular diagram. It comes by the extension of, again, locate all the links 1, 2, 3, 4, 1, 2, 2, 3, 3, 4 and 1, 4. Now we want 1, 3. 1, 3 is, 1, 3 eye center will be on the lines of intersection of eye centers 1, 2, 2, 3, 1, 4, 3, 4 extension. Where is 1, 2, 2, 3? This is 1, 2 and 2, 3 extension, and 1, okay, 1, 4, 3, 4. This is 1, 4 and 3, 4 extension. It is at this location, that is 1, 3. Next, the next one is 2, 4. This 2, 4 is the intersection of lines of eye centers 1, 2, 1, 4. This is 1, 2, and here also 1, 4 will come. 1, 2, 1, 4 and 1, 2, 1, 4, 2, 4, yes, 2, 3 and 3, 4. This is 3, 4 and this 2, 3. This is the eye center of 2, 4. Thus, we located the permanent, neither permanent nor fixed eye centers. Let us see. This is what. 1, 3 is located here, and 1, 4, this is 2, 4 is located. So, all the eye centers are located. Next objective is that we have to find out the linear velocity of the VB and the link AB, omega AB. That omega AB is here is omega 3, and velocity of the slider is slider link 4, V4 and omega 3. These two are required. So from the given data, they have given the crank angular velocity, that is omega 2, link 2, omega 2 are given. That omega 2 equal to 10 radians per second. Now from this, VB equal to We want linear velocity of the slider. Yes. Linear velocity of the slider, that is VA here. Okay, that VB equal to, how it comes, VB equal to omega OB times OB. What is omega OB? That omega OB equal to 10 radians per second. OB length is 100 millimeter. That is 0.1 meter per second. That is velocity of the point B. This velocity of the point B is a common to link 3 and 2. So from this we can find out the link, angular velocity of the AB. From that, how to find out the angular velocity of the AB? With the help of the mathematical relation. Okay, now that is VB, we can find out VB equal to omega 3 times I1 3B ratio. Then omega 3 equal to VB by I1 3 to B, point B, I1 3 to B. Thus we can find out omega 3B. Yes, you can see here that omega AB is nothing but omega 3, that equal to VB by I1 3B. That is 1 by 0.56. That is 1.78 radians per second. Now another is called velocity of the slider. This velocity of the slider is the common link having VA and VB on the link 3. So with the help of using this relation, that is VA by I1 3A equal to VB by I1 3B. Why it is? This omega AB, it is on the link 3. Both are having common angular velocity. That omega 3 equal to VA by I1 3A and omega B, that is VB, that is I1 3B. Now in this, we know VB and the distances I1 3B. This I1 3B is 560 millimeter and I1 3 to A, point A. This I1 3 is I centers 1 3 to A. This distance, if you measure, it comes as 460 millimeter. This 460 millimeter equal to 0.46 meters. Next, I1 3B. This I1 3B comes as 560 millimeter. That is nothing but 0.56 meters. Now VB by I1 3B, that is VB equal to 1, I1 3A 0.46 by I1 3B 0.56. Then what is VA? Velocity of the slider? VA equal to 0.82 meter per second. And what is the VB? That VB equal to 1 meter per second. So in that manner, we can calculate the unknown linear velocities and angular velocities of the various links of a given mechanism. Okay, very important in this in order to solve the problems of this type of problems, especially by using I-center method, what are the things, what are the prerequisites are required? The number of I-centers and concept of Arnold-Kennedy's theorem and the angular velocity ratio theorem or linear velocity ratio theorem is required. Here linear velocity ratio theorem, this VA and VB. Here another thing is that VA and VB, that same link. Now here, what are the things? This VB is common to two links, link 2 and link 3. And thus we can calculate the unknown velocity, linear velocity of the slider and also angular velocity of the link AB. Okay. That is what today we learned in this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.